So the first step is N2O, nitrous oxide, gets produced somewhere in your bioreactor. I already explained how. So there are three main pathways, either by these bacteria or either via the two pathways of the autotrophs. Okay, just imagine they would not produce any N2O, we would not have an N2O issue. So that's really the root cause, is these three pathways. So what happens secondly is, even though N2O is a gas, it is actually starting in the dissolved form. So it gets transported through the water flow of your system, and that makes it hard to, of course, know the root cause, because it's already going away from that. And you will measure it somewhere in the form of liquid N2O. And in a third step, and this is really causing the emissions, your N2O gets emitted because it gets stripped due to the aeration. So the liquid N2O joins the aeration bubbles, the air bubbles, and goes up, and this is really causing the emissions. So what we really measure is typically with liquid sensors or gas measurements, the N2O in the water phase or the gas phase. But really the root cause is here. And what is also important is what gets emitted is causing the climate impact. So we have to distinguish between what we can measure, what causes the climate impact, and what is the root cause of the problem. So if you approach this from an engineering point of view, we have actually two choices. So either we address the root cause, which means avoiding N2O to get produced or lowering the production of it, or we treat the gas, and that's an end-of-pipe solution. For some reactors, it works because they are covered. And then you also avoid the environmental impact. But of course, in this webinar, we will be focusing on step number one, which is really the root cause. And we believe if you understand the root cause, you can really effectively mitigate.